Hello dear students, welcome to Teja my YouTube channel. So in this video I am going to solve few numerical questions from the chapter Wave Optics. So let us start with this question in which we have in Young's double slit experiment, while using a source of wavelength 4500 angstrom, the fringe width obtained is 5 millimeter. If the distance between the screen and a plane of the slits is reduced to half, what should be the wavelength of light required to get the fringes of width 4 millimeter? First of all, let me write how the experimental setup looks like for YDS experiment. So if I consider this is a source of light, this is slit 1, S1, this is slit 2, and slit separation is given by small d. Screen separation from the slits is given by capital D. And when the light falls on the slits behaves as coherent sources, and lights from these coherent sources interfere each other and produce interference pattern on the screen like this. So you can see pattern on the screen. So here I'll consider central bright fringe, first bright fringe, second bright fringe, nth bright fringe on either side. So this is central bright fringe. So the distance between two consecutive bright fringes or dark fringes will give you fringe width. So the formula for fringe width here is given by beta is equal to lambda d by small d. So based on this experiment we have numerical here. To solve that I am going to erase this diagram. Okay. So in Young's double slit experiment, while using a source of wavelength, let me write the data. Lambda is given, that is 4500 angstrom, means 10 to the power minus 10 meter. The fringe width obtained is beta is 5 millimeter. Milli means 10 to the power minus 3 meter. If the distance between the screen and the plane of the slit is reduced to half, that is capital D is reduced to half, what should be the wavelength? Means we need to find out lambda 2. What should be the wavelength of light required to get the fringe width? Beta dash is equal to 4 millimeter, that is 10 to the power minus 3 meter. Very simple question. Here we need to find out lambda dash. So small d value is fixed, it is not varying. So therefore alpha consider beta lambda value of initial light is lambda 1 and initial beta is beta 1. So or just you can consider it as beta also, because here I have used beta dash. So using this, what is that? Using the expression for fringe width, what is that? Fringe width is given by beta is equal to lambda small d by lambda capital D by small d. Now for first wavelength, that is lambda 1, and d1, it is d only divided small d. So the fringe width is how much? 5 millimeter. 5 into 10 to the power minus 3, which is equal to lambda 1 is 4500 into 10 to the power minus 10 into d1 is d divided by small d is small d only. Next, for beta 2 or beta dash, we have lambda 2 d dash divided by small d. So beta dash is 4 millimeter 10 to the power minus 3, which is equal to lambda 2 is how much, and capital D is d divided by 2, that is d dash, small d as it is. If we divide these two and solve, so how much do we get? If you divide these two, you will get 5 into 10 to the power minus 3 divided by 4 into 10 to the power minus 3, which is equal to 4500 into 10 to the power minus 10 into d divided by small d, the whole divided by lambda 2 into capital D divided by 2d. What get cancelled here? Small d get cancelled, capital D get cancelled, 10 to the power minus 3, 10 to the power minus 3 get cancelled. Okay, and after solving this, you will get lambda 2 as 4500 into 10 to the power minus 10 into 4 divided by 5. So solving that, you will get 7200. Just a minute, something is missing here. Yeah, we have missed 2 also here. So actually this 2 will go to the numerator, so it will become 8. 7200 into 10 to the power minus 10 meters. So this is the answer for this question, lambda 2. The wavelength required is 10 to the power minus 10, means 7200 into 10 to the power minus 10 meter, or 7200 angstrom. This is lambda 2. Okay, let us move on to the next question. So dear students, this question is similar to the question that we have just solved in the first page. So this is the same question when compared to this one, only some data is changed. So you can write it and try to find the answer. Consider it as homework, and you can just reply your answer through the comment section if you want to involve in it. Let us move on to the next question. So here we have a beam of light consisting of two wavelengths, 420 nanometer and 560 nanometer, is used to obtain interference fringes in Young's double slit experiment. The distance between the slits is 0.3 millimeter and the distance between the slits and the screen is 1.5 meter. Compute the least distance of the point from the central maxima where the bright fringes due to both the wavelengths coincide. So let me show you what is happening here. If I consider the Young's double slit experiment here, so the separation between the slits is small d, separation between the slits and the screen is capital D. So this is slit S1 This is slit S2. Let's consider this is the screen. So here it consists of, the source consists of two different wavelengths. Let's consider due to 420 nanometer or 4200 angstrom. So we are getting interference pattern like this. This source also consists of one more wavelength. Let me consider this color. So due to this one also we are getting the fringes. Central bright fringe will be at the same position, but other bright fringes may not coincide. So at one particular position the fringes due to both of them coincide. So what is this least distance at which fringes due to both the wavelengths coincide? So you can consider that distance of nth bright fringe is given by n lambda d by small d. So that is, for first wavelength n1 lambda 1 into capital D is same, small d is same, which is equal to n2 lambda 2 capital D by small d. So n1th fringe of lambda 1 and n2th wavelength fringe of lambda 2 is coinciding, means they are coinciding. That's why we have considered that y distance for both the fringes is given like this. So if we cancel capital D small d, capital D small d, so we will get n1 lambda 1 is equal to n2 lambda 2. Therefore n1 by n2 is equal to lambda 2 by lambda 1. So where lambda 2 is 560 nanometer or 5600 angstrom, 420 nanometer is the lambda 1. You can cancel this and get the answer. So don't try to find the answer in fractions, but we need it in p by q form. So least value in p by q form is 4 by 3. Below that, if you try to divide, it will become like decimal points. So 4 by 3. So that means n1 value is 4 from this data. n2 value is 3. Okay. Now if I substitute that here, that y value becomes, you can use n1 lambda 1 or d by small d or n2 lambda 2 d by small d. So n1 is 4, lambda 1 is 420 nanometer, means 10 to the power minus 9 meter, into capital D value is given, that is 1.5 meter. Actually you have to write data also. Here I have not written. You please write the data. 0.3 millimeter, 10 to the power minus 3. So how much do you get if you solve this? Let me solve it and write the final answer. So I am getting around 8400 into 10 to the power minus 9. That is, y value is equal to 8.4. I think minus 9 plus 3 is minus 6. 8.4 into 10 to the power minus 3, that is 8.4 millimeter. This is the value of the distance y. So hope you have got the answer. This is very, very important. This question came in KCET exam, NEET exam, JEE exams also. So it's very important. When I have written KCET exam, this question was there in 2011. Okay. So let us move on to the next question. So here we have YDS experiment, that is Young's double slit experiment. The fringes of certain width are produced on the screen kept at a certain distance from the slits. When the screen is moved away from the slits by 0.1 meter, the fringe width increases by 60 micrometer. The separation between the slits is 1 millimeter calculate the wavelength of light used. So if I consider Young's double slit experiment, here so they are placed, the slits are placed at a certain distance, capital D, and slit separation is small d. So there is a screen here, sorry, there is a source here. This is a screen. On the screen you will get fringe width, what is that, the fringes. So here slit S1, slit S2, they behave as coherent sources. This is about this. In Young's double slit experiments, fringes are obtained with a certain width on the screen kept at a certain distance. It is not given, capital D value is not given. When the screen is moved away from the slits by 0.1 meter, when the screen is moved away by 0.1 meter, fringe width increases by, the change in fringe width is 60 micrometer. The separation between the slits is, small d value is given, 1 millimeter, means 10 to the power minus 3 meter. Calculate the wavelength of light used. We need to find out lambda. So for capital D, the fringe width is given by, that is beta 1 is equal to lambda capital D divided by small d. For beta 2, it is lambda only, but capital D value will be capital D plus 0.1 divided by small d. So if you subtract these two, what happens? If you divide, lambda will get cancelled. We want lambda value. So I will do beta 2 minus beta 1, that is equal to lambda d plus 0.1 minus, so divided by small d, minus lambda d by small d, that is equal to, you will get lambda d by small d, lambda d by small d get cancelled, lambda into 0.1 divided by small d will get. So beta 2 minus beta 1 is given, beta 2 minus beta 1, that is 60 into 10 to the power minus 6, that is equal to lambda into 0.1 divided by small d value is given. How much? 1 millimeter, 10 to the power minus 3. So if you solve this, you will get 60 into 10 to the power minus 6 into 10 to the power minus 3 divided by 0.1. That is 600 into 10 to the power minus 9 meter, that is 600 nanometer. Lambda value is 600 nanometer. So this is the answer for this question. Very easy question it is. So here we have one more question, that is in Young's double slit experiment, the distance between the slits is 1 millimeter. The fringe width is found to be 0.6 millimeter. When the screen is moved through a distance of 0.25 meter, the fringe width becomes 0.75 millimeter. Find the wavelength of light used. Similar to the previous question. So consider this as homework question. And you can send your answer through WhatsApp, through the comment. You can text your answer in the comment. I will check it. We'll meet you in the next video. Till then, take care. Bye. Thank you.